Hi fellas, and welcome back to the channel. In today's video we are going to build a really cool AVR project. External interrupts on the ATmega 2560 that display which interrupt was triggered on a 16x2 LCD. We will write the full code in the Atmel Studio, simulate it in Proteus, and I will explain everything step by step. So let's get started. So before we jump into the code, let me quickly explain what external interrupts actually are. Normally, your microcontroller runs through the main loop, the while one, doing whatever you told it to do, but sometimes something urgent happens, like a button press, and you need the MCU to stop what it is doing and respond immediately. That's exactly what an interrupt does. It literally interrupts the main program, jump to a special function called the ISR interrupt service routine, handles the event and then comes back to where it left off. The ATmega 2560 has three external interrupt pins: int 0 on PD0, int 1 on PD1 and int 2 on PD2. In this project, we will use all three, each one connected to a push button. Here what we are building: three push buttons connected to int 0, int 1 and int 2. Where you press a button, the corresponding ISR file and display which interrupt was triggered on the LCD. Simple but really useful for understanding how interrupt work in practice. So now, with the Proteus schematic, open the Proteus and create a new project. First, place the ATmega 2560, search for it in the component library. Double click it and set the clock frequency to 16 MHz. Next, place the LCD, search for LM016L. This is the standard 16x2 LCD in the Proteus. Now let's wire the LCD to port A on the ATmega 2560. RS goes to PA0, EN goes to PA1, D4 through D7 go to PA2 through PA5, VDD to 5 watt, VSS and RW to ground and VEE to ground for full contrast. Now for the button, place 3 push buttons and connect them to PD0, PD1 and PD2. The other end of each button goes to ground. We are using internal pull-ups in the code, so no external resistor needed. That's the schematic done. Pretty clean and simple, isn't it? So now we will go through the code. So Open the Atmel Studio, create a new GCC C executable project, select ATmega2560. At the top, we define FCPU as 16 MHz and include our headers AVR IO, AVR interrupt, and UTIL delay. Highlight LCD functions. Then we have our LCD functions. We are using 4-bit mode to save pins. The key functions are LCD CMD to send common LCD character, to send a character LCD print to print a string, and LCD go to position the cursor. In main, first thing we do is initialize the LCD and display system ready and waiting it as the ideal screen. Then we set port D as input and enable internal pull-up on PD0, PD2 and PD3 by writing 1S to the port D. EIMSK is the internal interrupt mask register. We use the int0, int1 and int2 bit to enable all three interrupts. EICRA controls the trigger condition. We are setting ISC001, ISC11 and ISC21 to 1 and leaving ISC00, ISC10, ISC20 as 0. This configures all three interrupts to trigger on the falling edge. So when the button is pressed and the pin goes from high to low, the interrupt fires. SEI brackets enable the global interrupt flag. Without this, no interrupt will work even if everything else is configured correctly. Finally, the three ISRs, each one clears the LCD position, the cursor, and print which interrupt was generated clean and straightforward. Alright, let's test it. Build the project in Atmel Studio. Go to the build solution, grab the hex file from the debug folder. Back in Proteus, double-click the ATmega2560 and load the hex file. LCD shows system ready waiting int. Now I will press the button 1 on PD0 and there is a int0 generated on the LCD. Button 2 on PD1, int1 generated. Button 3 on PD2, int2 generated. All three buttons working perfectly. So that's all. We have successfully implemented all three external interrupts on the Atmega 2560 and displayed the result on a 16x2 LCD. This is a greater foundation we can build on this to detect sensor encoders or any external event in our project. If this helped you out, drop a like and subscribe. It really helps the channel to grow. Comment below if you have any questions and I will see you in the next one. Goodbye.